All right, in this video we're going to go ahead and continue learning about ellipses, just finding information in different scenarios. So we can go ahead and say the title of this is still conic sections, ellipses. We're just continuing on. So we know that we have x minus h squared over a squared plus y minus k squared over b squared equals 1. We have one more vocabulary term for ellipses that we're going to learn about, and that's called eccentricity. The eccentricity of an ellipse determines how circular it is. So we have two different equations we use to find the eccentricity of an ellipse depending on what orientation it has. One is E equals C divided by A. The other is E equals C divided by B. And we know which one to use based on whichever one is bigger in the problem. So use A or B, whichever is bigger. This is another term that is not inside of your conic resource page, and so we're going to go ahead and add that. So we're going to say eccentricity E equals, and then in this particular orientation, it would be C divided by A because the A is longer. And over here, it would be E equals C divided by B because in this one, the B would be longer. Okay, so to start off, we're just going to make sure that we remember how to do all of the different things for an ellipse. So here's the equation. We're going to do x plus 2 squared plus y minus 3 squared over 16 equals 1. And for the instructions, we're just going to find everything. Normally I'll be more specific, but I don't feel like writing it all out. Okay, so we do need to graph this, which means we need to know what the center is. So left 2, up 3, negative 2, 3. And from there, we're going to have to go left and right 1 and up and down 4. Left 2, up 3, and up and down 4. Okay, so I got to have a lot of space to go up. It's not quite straight. That's better enough. Okay, so from here we're going to go to the right 1 and to the left 1, and then we're going to go up and down 4. So we have a pretty skinny, tall, skinny ellipse. Okay. So the vertices would be the points that went up and down. And we went up 4 and down 4. And the co-vertices are left and right, 1. And we can go ahead and find the foci. So we have c squared equals 16 minus 1, which is 15, and so c equals the square root of 15. And since the vertices went up and down, then that means that the foci go up and down as well. And we have the major axis and the minor. So the major axis is up and down, that's x equals negative 2. The minor would be left and right, that's y equals 3. And then if we want the eccentricity, we have c, which is the square root of 15, divided by b, which is 4. Right? And if you want, you can, exact answers are always good, but if you want to check the decimals just so you can kind of see how the decimals compare, after we do a bunch of these, we'll be able to make a conclusion about what type of numbers tell you that the graph is more circular versus less circular. So this decimal is 0.968. Okay. Well, we can go ahead and do the length for each of these. So the length of the major axis, since we went up 4 and down 4, that length would be 8. The length of the minor axis, since we went left 1 and right 1, that would be a length of 2. Okay, here's our next example. We are going to find the equation of an ellipse with a focus of 3, -3, and I guess I should have said that. And vertices at 5, -3, and -1, -3. Okay, so there's some information that we can get from this problem. And I would recommend always drawing a sketch whenever you do any sort of problem for this unit, because when you draw a sketch, you get to use your common sense to help you find some of the answers. So we have a focus. We know that the focus comes from a C value, so we know that somehow we can find the C value from this information. We have the vertices, which means that once we draw the picture, we can know if the major axis is horizontal or vertical. And if we know how far apart the vertices are, then we can find the center. And we also know that the vertices, since they're the wider part or the taller part, those are going to give us the B value. So we have enough information to get the B value, to get the C value, to get the center. And so from there, that's a lot of the stuff that we need to write the equation. We're just going to have to be able to find the A value. So what I'm going to go ahead and do is start drawing all of this stuff. So I have to be able to draw the point 3, -3, and 5, -3, and -1, -3. So 5, -3, 3, -3. Actually, I don't need to draw. I'm not going to draw the focus because we typically don't draw it, to be honest. Okay. So that's one end, that's the other end. So if I want to find the center, I just have to find the middle of those. So to do that, we can go ahead and use our midpoint formula. And you might write this in your packet, you don't have to. But to find our midpoint, and that's beneficial because the midpoint would be the center of the vertices or the center of the co-vertices, and it would literally be the center of the ellipse. We take the x-coordinates and add them together. So 5 plus -1. We divide it by 2, that's to find the middle. Take the y-coordinates and add them together and divide it by 2. So when we find that, we have 5 plus -1 is 4. 4 divided by 2 is 2. And then these, of course, if you find the middle between -3 and -3, it's just going to be -3. But technically that's -6 divided by 2. So that tells us that the center of this ellipse is 2, -3. Okay, so we have a lot of stuff that we can go ahead and start writing. We have x minus 2 squared over something plus y plus 3 squared over something equals 1. We do know the b value of the graph. So from 2 to get to 5 or from 2 to get to -1, that's a distance of 3. And so we know that this is the b value, because that's to the left and right. We know the b value is 3, and so 3 squared is 9. Okay, So from here, I'm going to say b equals 3. All right. Now from the center, to see how far we have to go from the center to get to the focus, if the center is at 2, -3, and the focus is at 3, -3, there's my center, there's my focus, then I know that my C value is a length of 1. Right? And now if I have B and C, I can go ahead and use my formula, C squared equals B squared minus A squared, or A squared minus B squared, whichever one is bigger minus smaller. I can use that to be able to find my A value. So I'm going to say C squared equals B squared minus A squared for this particular problem because the B value gave me my vertices, not my co-vertices. Okay? So C squared, if C is 1, then C squared is also 1. B is 3, so B squared is 9. So I'll go ahead and subtract 9 over. I have -8 equals -A squared. And so if I divide by -1 to make those both positive, then that means that A squared is +8. And since the equation uses A squared, I don't even have to square root that. I can just say that it's 8. So a lot of the problems that are going to be harder for us to do, where we really have to think through them and use our brain, are going to be problems where they give us some information and they want us to write the equation from that information. And so you have to be able to think backwards. The easiest problems we're ever going to do are the ones where they give us the equation and ask us to find everything. Those are pretty straightforward, they're pretty repetitive. These types of problems, we really have to think about the clues that they gave us and use those clues to write the equation. Okay, so we're going to go ahead and do another problem. You know, I just realized I kept calling this the B value, but we labeled it in our picture as A. I didn't mean to call it the B value. I meant to just say it's whatever one is bigger. So if that messes you up, I'm really sorry. I'll probably have to remake this video at some point, but that would have been the A value based on our packets and how we've been writing things. I guess I was thinking B as in bigger. So just a little reminder is that when you're looking at your packet, we're just saying whichever one is bigger. So formula A squared minus B squared, B squared minus A squared, whichever one is bigger minus smaller. Since my picture would have looked like this, my vertices left and right, that means that the A value was the bigger value. And so it meant I was using this equation. So again, if that confused you, I'm sorry. Okay, here is the next one. Find the equation of the ellipse where the major axis is from -6, 2 to -6, -8. And the minor axis is from -3, -3 to -9, -3. Okay, so in this problem, when they say the major axis, they're telling you basically the vertices, because the major axis is the longer one. That's the one that runs between the vertices. And so that means our vertices are -6, 2, -6, -8. And then the minor axis would be between the co-vertices. -3, -3, -9, -3. Okay, so just like before, we're going to go ahead and find the center because that's going to be really important. But we know that if we have the vertices and the co-vertices, then we have our A and our B value. We just have to look for them. So it doesn't matter which one you choose, but we're going to go ahead and find the middle. So with these, I can see that the -6 is the same, and so I know that the middle of that is just going to be -6. But if you want to go ahead and write the formula out, you can. And then 2 plus -8 divided by 2. And so that means that the center is at -6, and then -8 plus 2 is -6. -6 divided by 2 is -3. So it's actually kind of interesting if they give you the vertices and the co-vertices, it's kind of like they're giving you the center, because you can see like which coordinates don't change. So if the center is at -6, -3, and the vertices have an x-coordinate of -6, that means that the y values are what was changing. So we could go ahead and draw a sketch of this, but I'm going to show you guys kind of how to think through it. So if you are having a hard time picturing what I'm saying, then pause the video right now and draw a sketch. Okay? But if the center is at -6, -3, and the vertices have different y coordinates, that means that the vertices moved up and down. So that means that whatever distance we have between the center and each vertex is, that value would be the number underneath y. So I've got x plus 6 squared, y plus 3 squared. And if I look at this, I can see from -3 to 2 is 5. From -3 to -8 is 5. So the number that you would go up and down from the center is a length of 5, which means that the b value is 5, and b squared is 25. If we look over here, we can see that the co-vertices are moving left and right, and from -3 to -6 is a length of 3. From -9 to -6 is a length of 3. So the a value is 3, and that means a squared is 9. And there is our equation. And again, if you had drawn that, the center and the points, it would have been a lot more obvious what those numbers were. So anytime you're struggling with these problems, the first thing I'm going to ask you to do is draw a picture.